Welcome back. We're going to go ahead and do our 10.4 notes. These ones are much quicker, so don't even worry. Got a couple fill in the blanks that we need to take care of. We're going to talk about arc measures. I threw that word out a couple times last time. Now we're going to really dive into it. So we say a central angle is an angle whose vertex is the center of the circle. An arc is a part of a circle. And what we mean by a part is a part of the outside of your circle. A semicircle is half of a circle. Semi, part of. In this case, it's actually exactly half. When we talk about something that's less than a semicircle, we call that a minor arc. And if we want to talk about something that's bigger than a semicircle, we would call that a major arc. Now, a couple things to note about your arc measures. Do you notice that right here I use 3 letters for measuring an arc? Usually you need a minimum of 2, but if you need to ever indicate a direction for how you want to show it, you're going to use 3 letters. So you follow the path. The first letter and the last letter are your starting points. The middle letter tells you the direction. So that would mean I would start at T, go to R, end at S. So you would be reading it this way. Now, a semicircle, because a full circle has 360 degrees, makes the semicircle 180 degrees. It's a full half turn. In a minor arc, usually because it's less than 180, we only need 2 letters, and it's always going to be the shortest distance or the shortest arc between the 2 points. So in this case here, I'm looking at RS, so I'm looking for the shortest path here. Boom, big reveal. Now the arc, the measure of RS, is going to be equal to the measure of the angle of its central angle. I'll say that again. This central angle here is going to equal some angle. We'll say that it's 120 degrees. That angle is equivalent to the measure of its arc. Not the length, but the measure. The measure describes how many degrees does that arc take up out of 360. And then, of course, with the major arc, because you're more than a semicircle, this also requires 3 points. The first point indicating your starting spot, the next point describing your direction, and then your last point showing you where do I end. You're going to end right there. So in this circle, I ended up going in this direction. Now, a couple ways of doing this are doing what are called complements. And I don't mean compliments as, hey, your hair looks pretty. No, a complement in mathematics means the opposite. So if I say you are either in school or you are not in school, the complements are that they together make the entire picture. So you're either a student or you're not a student, right? If you're not a student, you could be anything else. But if you're a student, then you are specifically that one group. So what I mean by this is I'm saying, hey, the measure of angle RTS, the measure of arc RTS can also be found by doing 360 minus the measure of RS, because everything forms a full circle. So if I know one part and I want to find the rest, I could always do 360 minus the one part. And then of course, depending on what else you have, you could use different numbers, as I'll show you in the next examples. So first off here, we're going to identify the minor arcs. Now, I always tell you don't assume things, but there are some things here that are going to be a little more obvious than usual. So any combination of those two letters on the arcs, like let's say AC, that's less than a half circle, so that qualifies as a minor arc. So we could say AC, and I can put an arc symbol above. I could say CE, I could say ED, or I can say AD. Now for a semicircle, you just need a full half turn. So it could be something like this. So I can say CED. So here's CED with my arc symbol. I could even do EDA. I could also do DAC. And lastly, I can do ACE. Now, if you're wondering, could you switch the order of the letters around? Yes, you can go in the opposite direction. You could have said DEC. So I could have gone, oh, trying to mimic the video. Yeah, you could have gone counterclockwise or clockwise. The order doesn't matter. Just as long as your middle letter tells you the correct direction you need to go, so that you don't mistake it for something else. Now for a major arc that contains point A, that means I need this one. Well, for a major arc, I could say CAE, and if you think, well, how does that work, Mr. T? Well, C is my starting point, A is my direction, and the last letter is where I stop. Well, since I told you stop at E, you're going to skip right past D. So then that's one major arc. I could also do something else. I could say, if I don't start at C, maybe I want to start at letter D. If I want to start at D and I go through A, I could then say D, A, skip past C, and go to E. So that could be another major arc that goes through and contains point A. So that would be DAE, arc DAE. Now, the next theorem on our list of many theorems is the arc addition postulate. If I have two arcs that are adjacent to each other, I can always add them together and I can create a new angle. It doesn't have to be a right angle, it doesn't have to be a semi-arc, semicircle. It doesn't have to be anything special. Just if I have two that are next to each other, like AB and BC, then I could create a bigger arc by adding them together. So I could say AB plus BC equals arc ABC. Because then I create the entire thing. And again, we say that adjacent arcs are arcs that have the same point in common. In this case, the exact one point they have in common is B. So we're going to go ahead and use this postulate to help us with our next example. But before we go too much further, we need to define something. When we say arc measure, the measure of an arc is congruent to its central angle. And the measure of an arc is always in degrees. Key phrase, measure. Later on, we're going to be talking about arc length. And so it's going to be good for us to distinguish the difference between measure and length. You measure the arc in degrees. You find the length of it with a unit. It could be inches, it could be feet, miles, whatever we use. Something I like to do before I even look at these questions, I like to label what I do know about the picture. So right now, these 32 degrees can be written right here. The central angle is congruent to the arc measure. So right here is BC. And likewise, I could also say CD can send 58 degrees down here. Now we have to remember that there's a semicircle, and that's because this line here is our diameter. So that means that this angle here can be found by doing 180 minus 58. So that should give you 122 degrees. Which also means that this outside arc is 122 degrees. We can do the same thing on the bottom section. We could say that this angle equals 180 minus 32. So that should be 148. 148 degrees, which therefore also means that this arc here is also 148 degrees. So now I can go back to the problem and figure out, hey, what do I need? Right now I'm asked to find the measure of arc BC, which we did find right there. So BC is 32 degrees. On BD, since I'm given two letters, I need the shortest arc between the two, which is going to be that. So I'm going to do 32 plus 58, which should give me 90 degrees. Measure of ABC, notice that ABC is from here to here. Well, since that forms a semicircle, we can just say that that's 180 degrees. You could also check the math and you can say, hey, 148 plus 32, that'll also get you 180. Now the measure of AB, again, we're going to be doing the shortest distance between the 2 points. So there's my shortest distance, AB. That is our 148 degrees. And there you have it. That's the end of your lesson. So at this point, you should get started on your homework. Hopefully you've had enough time to get the notes down. If you didn't, just go ahead and finish the notes up at home. The videos are up on YouTube. Obviously you're watching them, hopefully. And just bug me if you have any questions. I hope you're all doing well. I'll see you later.